Welcome back to Global Site Engineering, real experience. This is part 2 of our piping masterclass. Let's dive into advanced piping concepts every site engineer and QA/QC professional should know. 11. Pipe manufacturing methods. Pipes can be manufactured using different methods, each with specific use cases. Seamless pipes are made without any welding seam. They are ideal for high pressure and high temperature lines. ERW, or electric resistance welded pipes, are joined along their length and are commonly used in structural and low pressure systems. Spiral welded pipes are formed by helical welding, suitable for large diameter pipelines in low pressure applications. Why is this important? Because the manufacturing method affects pipe strength, cost, and inspection scope. 12. Pipe end connections. Let's look at the ways pipes are connected in the field. Butt weld ends, where pipes are welded directly end to end. These offer strong, permanent connections. Socket weld ends, where one pipe fits into another and is fillet welded, common in small bore systems. Screwed or threaded ends, used in low pressure or small diameter piping. Flanged ends, allow easy disassembly. They are joined using gaskets and bolts. 13. Piping material specifications or PMs. Large industrial projects follow a piping material specification, known as PMs. It includes pipe grade and schedule, operating temperature and pressure rating, corrosion allowance, required testing like NDE or PMI, and line class coding, for example, 150-pound carbon steel or 300-pound stainless steel. Every piping engineer and QA/QC inspector must understand PMs before execution or inspection. 14. Thermal expansion and pipe stress. Pipes expand or contract due to changes in temperature. Improper design can lead to cracking or flange leaks. That's why engineers include expansion loops, bellows or flexible joints, and sliding or spring supports. A proper flexibility analysis using software like Caesar2 helps avoid failures. 15. Common piping failures and causes. Here are a few failure types you must know. Corrosion, caused by chemical attack or improper material selection. Flange leakage, due to worn gaskets or improper bolt torque. Support failure, missing or broken pipe supports, especially under thermal movement. Weld cracks, usually from poor welding or lack of proper NDE. 16. Pipe insulation types. Insulation is used to manage temperature and safety. Hot insulation like calcium silicate is used for steam and hot oil lines. Cold insulation such as polyurethane foam is used for chilled water or LNG lines. Acoustic insulation is applied on gas lines to reduce noise. 17. Color coding and pipe marking. Industrial sites use color codes to identify fluid types in piping. Green, for water. Yellow, for flammable gases. Red, for firefighting lines. Blue, for compressed air. Black, for oil or waste lines. Flow direction is marked with arrows, and each line is tagged with a number that corresponds to the P&ID drawing. 18. Safety precautions in piping work. Piping work is high risk. Here are key safety measures. Always wear PPE, helmet, gloves, safety goggles, and ear protection. Ensure the line is depressurized before starting any work. Use lockout and tag out procedures for isolation. Watch for hot surfaces, chemical residues, or pressure buildup. During radiographic testing, cordon off the area and post radiation warning signs. 19. Career roles in piping engineering. Let's look at some of the key roles in a piping project. Piping engineer, responsible for design, layout, material selection, and stress analysis. QA/QC engineer, ensures inspection, documentation, and code compliance. NDT technician, performs non-destructive tests like RT, UT, and DPT. Fabrication supervisor, manages fit-up, welding, and fabrication on shop or site. Commissioning engineer, handles system flushing, leak testing, and startup activities. This concludes part 2 of our piping masterclass. If you found this useful, please like, comment, and share this video. And don't forget to subscribe to Global Site Engineering for more practical engineering knowledge from real industrial projects. See you in the next video.